Ever stop and wonder how your phone can stream a movie, juggle a dozen text threads, and check your email, all at the exact same time without completely falling apart? Well, the answer isn't just a bigger processor, it's a smarter highway. Today, we're going to pull back the curtain on the invisible blueprint that prevents digital traffic jams in pretty much everything you own. Let's dive in. So, this all starts with a company called ARM. Now, you've probably heard of them. They don't actually make the chips themselves. Instead, they're the architects. They design the fundamental rules that everything else is built on. And one of their most important, yet kinda unknown creations is a standard called AMBA AXI.
And that really gets to the core of the problem, right? A modern chip, what we call a system on chip, isn't just one brain. It's like a whole miniature city packed with specialists. You've got the CPU, the GPU, the memory controller. All of them are shouting, demanding to talk to each other at lightning speed. Without a really brilliant traffic management system, you'd have total gridlock. Okay, so here's how we're going to break this all down. First, we're going to peek inside our gadgets to really see the scale of this problem. Then, we'll get to the solution, the AXI data superhighway. We'll look at the clever rules of the road that make it work, see how it's had to evolve to get even faster, and finally, we'll connect it all back to why this invisible standard is just so incredibly important.
So yeah, let's start with what's actually happening inside that phone in your pocket. It's not just one thing doing all the work, it's this entire orchestra of specialized electronics. Every single tap, every swipe, every notification requires all of them to coordinate perfectly. It's like a dance of data happening billions of times a second. Kind of wild when you think about it.
And when you have that many players in such a tiny space, you run into a huge communication problem. I mean, imagine that entire city of components crammed onto a piece of silicon the size of your fingernail, all trying to talk at once. It's a recipe for absolute chaos.
Seriously, just picture it. A busy city with no roads, no traffic lights, and no rules. That's what a chip would be like without some kind of protocol to manage the flow of data. Requests would collide, information would get lost, and your device would just freeze. It would be a very expensive paperweight. So yeah, a master plan is absolutely essential.
And that master plan is AXI. This is the elegant solution that comes in and brings order to all that chaos. It's not a physical thing, it's a set of rules, a protocol that acts like a perfectly designed data superhighway, connecting every single part of that chip city.
So what is it officially? Well, AMBA AXI is a protocol for a high-performance communication network on a chip. Really, it's built for two things. High bandwidth, which means moving a ton of data, and low latency, which means doing it incredibly fast with almost zero delay.
At its core, this AXI highway has three key players. First, you've got the master, which is something like the CPU. It's the one that starts a request. It decides it needs some data. That request travels through the interconnect, which is basically the road network itself. And its destination is the slave, like your system's memory, which has the data and fulfills the request.
Okay, so we've got the players, and we've got the highway. But what makes this system so ridiculously efficient? Well, the magic is in the rules of the road. A few surprisingly simple design principles that allow for just incredible speed.
The secret is specialization. Instead of one giant chaotic road, the AXI highway is split into 5 independent one-way channels or lanes. Each one has a single specific job. And this separation is the key. It means a component can be sending out an address to write to, sending the actual data for that write, and receiving a confirmation from an earlier task all at the same time. No traffic jams.
Let's break down these 5 lanes real quick. For writing data, there are actually 3. First, the write address channel says where the data is going. Think of it as the GPS coordinates. Then, the write data channel sends the actual information, the package itself. And finally, the write response channel gets a little delivery confirmed message back. Reading is even simpler. One channel to ask for the data's location and another for the data to be sent back. By separating all these steps, the whole system can juggle multiple things at once.
But wait, with all these data vehicles flying around, how do you prevent crashes? How does the sender know that the receiver is actually ready to catch the data? The answer is this incredibly simple and really elegant traffic control system.
It's a two-way handshake. The component that's sending the data raises a signal called valid. This is basically the sender shouting, "Hey, I've got a package for you and it is ready to go right now."
The receiving component only raises its signal, called ready, when it's absolutely 100% able to accept that package. And here's the beautiful part. The data transfer only happens in the exact clock cycle when both valid and ready are active at the same time. It's a perfect sync. This simple rule prevents data from ever being lost or sent to a component that's too busy to handle it. It's genius.
But tech doesn't sit still, right? As our devices have gotten more and more powerful, the amount of data traffic has just exploded. So the XN highway has had to evolve. It's had to get bigger and smarter over time. The highway has definitely been widened over the years. The original, AXI-3, laid the foundation way back in 2004. But as chips got way more complex, we needed more bandwidth. So in 2010, AX4 came along, and it allowed for much longer convoys of data in a single request, which is perfect for moving big chunks of video or graphics. And then more recently, with the rise of AI, AX5 introduced new optional features to better manage those unique, high-priority data streams that machine learning needs.
Okay, so that's the how, but let's zoom back out to the why. Why does this invisible protocol matter so much? Well, to put it simply, without it, our modern digital world just couldn't exist the way we know it.
Without something like AXI, chip communication would be totally chaotic. It'd be slow and it'd be proprietary. Every single company would invent their own system and nothing would work together. With AXI, you get an organized, high-bandwidth, universal standard that allows components from hundreds of different designers to all speak the same language. It creates this huge ecosystem where new innovations can just be plugged in like Lego bricks. Ultimately, every single design choice we've talked about, from those 5 independent channels to that simple valid-ready handshake, is engineered for one thing and one thing only: maximum performance. The whole system is built to move the most data as quickly and as reliably as humanly possible. AXI is the ultimate unsung hero. It's this elegant, powerful standard that brings quiet order to the microscopic chaos inside every advanced piece of tech we use. So the next time you stream a 4K video while downloading an update, just take a second to remember the invisible superhighways inside, making it all happen.